We are on sequences and series, page 17, B7. If the sum of the n terms of an arithmetic series is equal to 840, then find the value of n. Now, we sum to n terms, formula is equal to n over 2 into 2a plus n minus 1d, and we are given the sum as 840. Therefore n over 2 into 2a is 162, and you'll notice d is 79 minus 2, so that's minus 2 into n minus 1, and that is equal to 840. Now the equation, when it is simplified, it would be minus 2n squared plus 82n minus 840 equals 0, and that is n squared minus 41 n plus 420 equals 0, and then we got n is equal to 21 or n is equal to 20. So both answers are acceptable. Page 18, number 16. In a geometric series, the sum of the first three terms is 31. The sum of the next three terms is 3875. Find the 10th term. So the sum of the first three terms, don't have to use a formula. Sum of the first three terms is a plus AR plus AR squared, and that equals 31. And the sum of the next three is equal to AR cubed plus AR to the 4 plus AR to the 5, and that is equal to 3875. Now here we will take out the common factor, which is a into 1 plus r squared, and that's equal to 31. And on the other side we will take AR cubed as a common factor, and we will have 1 plus r squared, and that's equal to 3875. Now what we can do is we can divide these two equations, divide the left hand side by the left hand side and the right hand side by the right hand side. Now when we do that, we will end up with r cubed equals 125, and then r is equal to 5, and then we are looking at the value of a, so we substitute for r. We will get a plus 5a plus 25a is equal to 31, and then a is equal to 1. Now if a is equal to 1, T10 is equal to AR9, which is a is 1, you can ignore that, and then we got 5 to the index 9. Problem number 23 on page 18. A ball is dropped from a height of 15 meters. It rebounds 3/5 of its original height each time. Find the total distance covered by the ball before it comes to a rest. And let's just quickly draw that. And it's dropped from a height of 15 meters, which means it will go up 3/5 of the distance, and 3/5 of 15. 5 will go there, that will give you 9 meters, and then it will come down 9 meters, and then it will go up 3/5 again, and it will come down. Now it's clear that from this problem that the ball will not come to it will continue and it will not come to rest. So therefore we're looking at a case of the sum to infinity. So our distance that the ball would cover will be 15 plus 2 times 9 plus 2 times 27 over 5, and it carries on. And then 15 is on its own, and let's remove the 2 as a common factor, and we'll get 9 plus 27 over 5, and it will continue like that. And therefore we're looking at sum to infinity, which is a over 1 minus r, and our r obviously is the 3/5, so which is 9 there as a first term over 1 minus 3/5, and that would give you 9 divided by 2/5, and that would give you 45 over 2. And then we're looking at the total distance is 15 plus 2 times 45 divided by 2, and that would give us 60 meters as a total distance. This problem here is a recurring decimal fraction, which we need to convert back to a common fraction, and this is 0,1 to recurring. Now, expressed as a common fraction, you got 0,1 to recurring, so we can actually rewrite this as 0,12. You'll notice the 2 continues indefinitely. And then we can write this as a sum, as a series. The first one is 1 over 10, and the 2 here will obviously be 2 over 100, and the next 2 will be 2 over 1000, and the next 2 will be 2 over 10,000, and so on. Now you'll notice that we 1 over 10, and we can remove common factor 2 over 100, and then you'll get 1 plus 1 over 10 plus 1 over 100, and so on. Now one can see straight away that this is sum to infinity. So you notice sum to infinity is quite a useful tool, and the sum to infinity a over 1 minus r, and since your first term is 1, which is a, and therefore your second term will be r, and that's 1 minus 1/10, which is 9/10, and that gives you 10 over 9. So I'll go back and say 1 over 10 plus 2 over 100 times 10 over 9. And when we add that, you will get 10 over 100, and when it's simplified, you will finish off with 11 over 90. This problem is number 26, and it says if those 3 terms form an arithmetic progression, then find b in terms of a. So if it's an arithmetic progression, the second term minus the first will be equal to the third term minus the second term. So what you notice here now, you've got a minus b into a plus b as being your LCM. So we can multiply throughout by a plus b into a minus b. So the first term will become a plus b, and minus 2 into a minus b, and then you've got a plus b will go the a minus b, and that has to be multiplied by a minus, and then you've got a plus b times 1, which is the numerator. And when you remove all this, when you simplify, you get a squared minus ab minus 4b equals 0. And then you've got to make b the subject of the formula, and then you've got b into a plus 4 is equal to a squared, and then you got b is equal to a squared divided by a plus 4. This is problem number 30, and incidentally it is a problem that appeared in the national benchmark test, and you'll notice how easy this problem is. We've got three angles from a triangle. The triangle, what you have basically, the three angles of a triangle form an arithmetic sequence. So let's call these three angles P, Q and R. So angle P plus angle Q plus angle R. Now if we say let P be the first term, which is A, then the second term is A plus D, and the third term is A plus 2D, and all that's equal to 180 degrees. So if you look at this carefully, you got 3A plus 3D is equal to 180 degrees, and then A plus D. A plus D is equal to 60 degrees, which is the middle angle if you look at that. This is C1.3. This is basically the one on patterns, non-standard sequences, special sequences, etc. So if you look at this now, 1.3.1, you are now given that we've got one distinct triangle for the first figure, second figure, 4, and so on. And one would straight away notice that these are square numbers, 1 squared, 2 squared, 3 squared as it appears. So T20 would be 20 squared, which is 400. And then we've got Tn, the n term, Tn obviously would be n squared. Then we're looking at 1.3.2, which says all possible triangles, 1, 5, 13, and it goes on to 25. Now if one had to look at the first difference of these problems, you'll find it is 4, 8, 12. Now that doesn't give you a constant, so therefore it's not linear. Look at the second difference, and it is the second difference works out to be a constant, therefore it's a quadratic. And now you can easily deduce this. Instead of learning these things by rules, take an squared plus bn plus c, and take t1, t2, t3. You'll notice that eventually your second difference will become a constant. Okay, and now here what we have to do is to look at this problem here. And what I want to say is, since your second difference is a quadratic, then one of the things you should know is that 2a is equal to 4, and then a is equal to 2. And then when a is equal to 2, now the problem would become very easy. You'll find when I told you to take T1, T2, T3, T1, T2, T1 is equal to A plus B plus C. T2 is equal to 4A plus 2B plus C. And T3 is 9A plus 3B plus C. And you'll find when you subtract, this is 1 obviously, that's 1, and this is 5. Now when you subtract, you'll find you get 3A plus B, and that equals 4. And then we've got A, which is 2, so B is equal to minus 2. and if you substitute in the first one, we will get A2 plus minus 2 plus C equals 1. And then you got your C equals 1, and therefore your nth term, now the one T20, Tn, your nth term is 2n squared, substituting for A, B, and C, 2n squared minus 2n plus 1, and then your T20, you can answer them in any order, which is 800 minus 40 plus 1, and that is equal to 761. Then we've got 1.3.3. Now 1.3.3, you'd have realized straight away you've got 13610. 13610, and we know this is triangular sequence, so let's not dwell too much on this triangular sequence. We know that the nth term is n into n plus 1 divided by 2. In other words, if you take n to be 1, 1 times 2 over 2 is 1, 2 times 3 over 2 is 3, and then your T20 is 20 times 21 divided by 2, giving us 210, and then you go 1.3.4, 0, 1, 3, 6. Now this question was the 1.3.3 was a triangles facing upward. Now this problem is a triangles facing downward. Now you'll notice from 136 it is also a triangular sequence. Now the difference here is the formula is n into n minus 1 all over 2. So if you test when n is equal to 1, 1 minus 1 is 0, n equals 2, and then it satisfies that. And then you want T20, which is 20 times 19 divided by 2, giving us 190.